Oh, my face is missing. Good morning. What's going on with my webcam here? Ooh. There I am. Aha! The magic. The magic of Open Broadcast System. OBS. Good morning. Or good evening, or good afternoon, depending on where you might be or when you might be watching this. If you're watching it live with me right now, it is, and you happen to be in Arizona, it is 5:34 a.m. Beautiful, beautiful morning here in Arizona. And I am here. I'm going to do the Advent of Code, Day 1, Advent of Code. If you're not familiar with what the Advent of Code is, it is the... What is Advent of Code? Advent calendar. Advent calendar, I think, is a Christmas thing. Advent calendar. So when I was younger, we'd get these calendars, and they'd have little chocolates inside. So you have, starting on December 1st, you have this little calendar. You open up one a day until Christmas. We would make these like rings. We'd make these chains with these little paper rings and connect them together, and you take one off every day, counting down to Christmas. Anyway, I actually don't know the history of Advent. I don't even know what the word really Advent means, but I know what the Advent of Code is. That means in December, every day leading up to Christmas Day, December 25th, there is a new coding puzzle for us to solve. And actually there's two. There's usually two. So you come in here and you complete part 1, and they usually give you a second puzzle to solve. So the goal is that, well, let's read it. Let's read it. Santa's reindeer typically eat regular reindeer food, but they need a lot of magical energy to deliver presents on Christmas. For that, their favorite snack is a special type of star fruit that only grows deep in the jungle. The elves have brought you on their annual expedition to the grove where the fruit grows. To supply enough magical energy, the expedition needs to retrieve a minimum of 50 stars by December 25th. Although the elves assure you that the grove has plenty of fruit, you decide to grab any fruit you see along the way, just in case. Collect stars by solving puzzles. 2 puzzles will be made available on each day in the Advent calendar. The second puzzle is unlocked when you complete the first. Each puzzle grants 1 star. Good luck. The jungle must be too overgrown and difficult to navigate in vehicles or access from the air. The elves' expedition traditionally goes on foot. As your boots approach land, the elves begin taking inventory of their supplies. One important consideration is food, in particular, the number of calories each elf is carrying. This is your puzzle input. The elves take turns writing down the number of calories contained by the various meals, snacks, rations, etc. that they've brought with them, 1 item per line. Each elf separates their own inventory from the previous elf's inventory by a blank line. For example, suppose the elves finish writing their items, calories, and end up with the following list. Based on the input, based on what they're saying, there would be 1, 2, 3, 4, 5 different elves. And each one of these sets happens to be, each one of these chunks of numbers happens to be the calories 1 elf is carrying. This list represents the calories of the food carried by 5 elves. Hey. The first elf is carrying food with 1,000, 2,000, and 3,000 calories, a total of 6,000 calories. The second elf is carrying 1 food item with 4,000 calories. Third elf is carrying food with 5,000 and 6,000 calories, a total of 11,000 calories. The fourth elf is carrying 7, 8, and 9,000 calories, a total of 24,000 calories. The fifth elf is carrying 1 food item with 10,000 calories. In case the elves get hungry and need extra snacks, they need to know which elf to ask. They'd like to know how many calories are being carried by the elf carrying the most calories. In the example above, this is 24,000. All right. Find the elf carrying the most calories. How many calories is that elf carrying? Okay. So we're gonna break these up into chunks, sum up those chunks, and then find our answer. We're gonna get our puzzle input. What's cool is every person, I think it's generated, at the very least, I'm pretty sure it's generated, every person gets their own inputs. And this is giant, so doing this by hand is not impossible, but improbable maybe. We have one viewer. I don't know who that viewer is, but if that viewer would like to make a suggestion on what programming language we should use, I'm open to that. Otherwise, I'm gonna do some C#. I'm teaching C# later today, so I'm gonna do C# and might just give this problem to my students. Oh, let's make a repository for my advent. All right, GitHub. GitHub, let's create new repository. Advent of Code 2022. Create. Let's clone it. All right. Open up a terminal. Boom, boom, boom. See, where am I? Let's go to my D drive. Oops. Get clone. Advent of Code 2022. Okay, let's make a directory for day one. Day one. This first puzzle is fat elves. They're eating all the calories. Maybe some of them don't have a lot of calories. One sec. I'm about to sneeze. I'm gonna mute myself. And we're back. Sorry about that. Sorry about that. No one wants to watch me sneeze and then use a tissue and then rinse my hands off real quick. You probably don't even want to hear about it, but it's too late. What's done is done. The damage is here. Okay, day one, fat elves. We're gonna do C#. So we're in VS Code. We're not in Visual. We're not in like some fancy Visual Studio is what I was gonna say. We're not in fancy IDE, but we're gonna create a new console program here. Okay, and so we have this program. So yes, let's add. Well, let's open up our project here. Code. As usual, we're listening to Harris Heller Stream Beats. This is 2021 album, Candy Shop. It's sort of a it has a very holiday vibe to it, in my opinion. Let's make sure we're not committing our bin object in VS Code folder. So we're gonna ignore bin, obj, VS Code. No one needs those. Really, no one's gonna be checking this out but me, so I guess I could do it. But I'm gonna save myself a little bit of space. Okay, we have our program.cs. We are gonna download our puzzle input. Puzzle input. Let's put that into our Git repository here. Advent of Code. Oh. I put it in the wrong folder. That's okay. We'll move that momentarily. Puzzle input, save it. All right, so the first thing we gotta do is I guess we can get our puzzle input in. So file dot let's see. Do I want to read it as one big file or a bunch of lines? I think I want to read it as lines. Yeah. All right, so I'm going to do this first as sort of the straightforward approach, and then I'm going to do the over-engineered approach. So we're going to read all the lines, puzzle input.txt. So now I have a string array data, and I need to iterate over all of these. So I'm going to do a for each loop. For each string line in data. And for now, we'll just console.writeLine, make sure that we're actually reading things in and outputting them. .NET run. Yeah, and it just chunks out the data for us. So we have a couple things here. So we're going to, this is an aggregate problem. So each time through this, well, not each time through this loop, we need to sort of break it up into chunks. So I need to check when I have a blank line. All right, so when I have a blank line, that means I'm about to reset. Okay. So I need something that's like if line is blank. All right, so we're gonna go ahead and trim these up. So I'm gonna do line equals line.trim. I'm assuming they have that in there already. Oh, can I not do that? Line is not null here. Cannot assign line because it is in a for each. Ooh, I didn't know that. I thought I could change it even. Okay. I knew I wasn't updating the variable in the list. All right. Let's do string clean line. All right. And so we're gonna say if clean line is the empty string. We have the empty string, console.writeLine new elf. Just to test our program real quick here. Else we output the calories. All right. .NET run. Yeah, there we go. New elf. So the idea is each time we get a new elf, we sort of reset the very first elf, I'm pretty sure. Let's do something real quick. By pipe, so this is called a pipe. Oop, does head not work here? Let's try cat. That head. What? I don't know. I wanted to see all right, here we go. We're gonna run this output. I just want to see, oh, we have hello world. Yeah, the very, very first line doesn't happen to be empty, so we gotta initialize things here. So int calorie count 0. And what we're gonna do is we're gonna take this line, we're gonna turn it into an integer. We're gonna add it to calorie count here. All right, so we'll say calorie count plus equals, and we gotta parse. And so in C# we can do int.parse line. So we're gonna add that to the calorie count. And when we get to the empty string, we're gonna say last elf's calories. And we'll output calorie count. Right, and we're doing string interpolation, so I got to put a $sign here. This $sign is unnecessary. That's a JavaScript thing. I've been programming in JavaScript, so. And then we want to reset calorie count equals 0, because every time we get to a new elf, calorie count's reset. Let's check it out. Nice and simple. Oh, to the output, that's fine. All right, so now we get each elf's calorie count, like so. Now we just gotta find the max one. Okay, so to find the maximum, we're gonna say int max calories. Started at 0. we know these can't be negative, you might do int dot min value initially. Say, okay, well, nothing can be less than the minimum value. And each time through the loop, before we reset, we're gonna set max calories equal to, so you could do it this way. We could say if the calorie count is greater than the max calories equals calorie count. This is one way we could do it. Say, all right, we're gonna keep the maximum there, and at the very end, we'll do a console.writeLine. The fattest elf has max calories. Okay, so we could do it this way. We'll do it that way real quick. So nice and short. Well, I don't know if nice and short. You have to know how to read a file, do some stuff. But the fattest elf has, in my case, 71,000. 71,000. So let's go test that. Submit. Hey, we get a gold star. Those reindeer might have enough magical power. All right. Part 2. All right. By the time you calculate the answer to the elves' question, they've already realized that the elf carrying the most calories of food might eventually run out of snacks. That's a lot of snacks. It's a lot of snacks. That's almost, if you're doing 2,000 calories a day, that's like, what is that? It would be 60,000 would be about a month. So you got a little bit over a month worth of calories for one person, I suppose. I don't know how many calories an elf needs, though. To avoid this unacceptable situation, the elves would instead like to know the total calorie count. The total calorie carried by the top 3 elves carrying the most calories. That way, even if one of those elves run out of snacks, they still have 2 backups. In the example above, the top 3 elves are the 4th elf, the 3rd elf, and the 5th elf. The sum of the calories carried by these 3 elves is 45,000. All right, so we just gotta get the top 3, sum them together. Not too bad, not too bad. All right, so here's what's our plan? I could have 3, keep 3 integers and do some craziness here, but I'm not gonna do that. Instead, I'm just gonna keep the sums. I'm gonna have a list of int calories. All right, come on, C# autocomplete. We're gonna keep a list of all the elves' calories, and then we're just gonna sort the list and get the biggest one out. There's not the right word. There is a more efficient solution where we don't have to loop through the list and then sort them. But here's what we're gonna do. Instead of getting the max calories, we're gonna get rid of max calories here. Oh, I guess I should save this as part 2. All right, so here's what we're gonna do. We're gonna write a function, void part 1. We're gonna wrap this bad boy as a part 1. All right, so we don't lose our part 1. Format it. Okay, part 1. Add a little comment to ourselves. Calculates. Oh, I should have this taken data. String data. Calculates the elf with the most calories. All right, so that one's going to calculate the elf with the most calories. Now we're going to do part 2. Void part 2. All right, this one I'm going to just keep a list. All right, so I'm going to have a list int all calories like this. And the idea, they're just a sort. The idea is that I can sort this and then take the last 3 elements. Because it sorts ascending by default. Let's see. Sort, can I tell it which direction to go? I can write a comparator, but I'm gonna be lazy. I'm gonna tell it just sort, and then we're gonna get the last 3 elements of the list, add them together. All right. So our loop's gonna look almost identical here. So we'll start with that. I'm gonna copy and paste. We shouldn't copy and paste typically. Copying and pasting is for suckers. But for now, we'll do it. For now, we'll do it because we got to think through the problem a little bit. Okay, we're gonna need calorie count. All right. So we're actually gonna loop through for each line. Oh, this should be a string array. And rather than saving the max, we're actually gonna say all calories dot add, dot add calorie count. So it's just gonna add in the calorie count like this. And then at the very, very end, we sort them. And then we're gonna pull out the last three. So in C sharp, curious, in C sharp, can I do the following? Can I do this? Oh no, I don't know if I can do that. Let's try it. Last element. Let's run part 2. Console.log last. Console.write. I've been doing too much JavaScript. That's how you know. Let's check this out. We'll call part 2 with our data. Yeah, we can't index any numbers. I think in Python, if you did -1, it says, get me the last element. Okay, in this case, we are going to sort it, and then we're gonna get the last 3 elements. So we're gonna do a substring. Sorry, subarray. All calories dot. Can I do a sub? Is there a subarray here? There's not. Oh, that's too bad. That's too bad. What's the best way to do this? I'm trying to think. Is there a nice way to get the last 3? Chunk maybe? All right. List sub C sharp list sub list. How do I get a sub list in C sharp? Get range. Okay, I knew they had to have it. First index and count. All right, get range. Takes an index and then the number of things we want. So we want 3. And then the index we want happens to be last. All calories dot count minus 4. Because the last index would be -1. So we got to go back 3. So we're going to do -4. Oh, what did I do? Oh, and it returns a list. Sorry. List of int. Like that. Then we just got to add them up together. So we're going to say int sum is equal to last element dot aggregate. All right, we'll do it the lazy way. Not the lazy way. I'm going to show you. I'm going to do it the for each way, and then we're going to use the link library. All right, so int total equals 0. Then we do a for each. Int calorie in last element total plus equals calories, and we'll display the total out here like that. And we'll display a message that's more readable. The top 3 counts are the sum of the top 3 calorie carriers is calories. Okay. So it sort of took the original puzzle, made it a little bit harder. And we got 200,953 calories. Let's see if that worked out for us. Ooh, what did I do wrong? It's not right. The answer is too low. I probably missed one or something along those lines. Let's see. Have a little issue here. Uh-oh. All right. Plus equals calories. So the right line total equals, so we'll do total plus calories equals, and we should get 3 lines. My thought is that I actually didn't want -4, but we'll see. 1, 2, 3. Interesting. Interesting. Oh, do I have a new output I need to get? Turn to day 1. I don't think so. Although it hasn't changed, same puzzle input. All right, what did I run? By the time you calculate the answer to the elves question, well, I know I'm only getting 3, but maybe I have the index wrong. I thought it should be -4. Let's see if this blows up here. I had the index wrong. Why is that? Creates a shallow copy. Of a range of elements. Shallow copy. Why? So if I did count, that would be the last one. I'm a little confused by this as to why that index works. So let's say I had 5 things. The last index would be 4, but if a 5, 4, 3, 2, so I need 2. Yeah, I'm just bad. I'm just dumb here. So -3, not -4. -3. Let's do it. This is the answer. Although I've said that before. This is my new submission. There we go. Got 2 gold stars. A victory. A victory with 2 gold stars. All right. So that's it for our advent of code. It's a little tricky here. So let's think about how we could engineer this a little bit better. Like I said, we have some repeated code. We are repeating ourselves. This is almost identical to this. Yes. So that's a little bit that triggers me a little bit. Maybe we say, oh well, this is a one-off puzzle, it doesn't matter. But let's think about how to do that. This, like I said, this is an aggregate. This here is an aggregate function. So what we're doing is we're looping through data and building up a result, max calories. For both of these, it's sort of the same. It's the same aggregate. Oh, it's the same data. So let's see if we can do this in a little bit more clever way. So we're gonna do data.aggregate. Look at that. In C# we have what's called an aggregate function. It's a little bit tricky. And then it's gonna take in a function which says how should we accumulate this stuff. All right, so how should we accumulate it? So the first thing I actually want to do, let's see, is that right? Let's see here, aggregate. So we're gonna have a function. I can't remember the order here. But I think it's string seed accumulate string. This isn't quite what I want. I want this thing. All right. Yeah. This is the one I want. This is the one I want. So the accumulate, it says, okay, well, what do we start with? The thing we start with, it happens to be a new list of ints. All right. Then Hang on. We're gonna start with a new list of int. So we need to build up our list of integers, right? And then our accumulator function happens to be the following. So it's gonna be list. List. So this is our aggregate. This is the list we're building up. And then the element that we are looking at. It's a little tricky. I don't think we can quite use this one here. But we're gonna try to come up with a excuse me, a function to abstract this. The idea is we want to loop through, and then the only thing that changes, the thing you'll notice is each time we get to an empty line, we do something slightly different. So let's abstract this. I'm gonna pull this out down here, and I'm gonna call this process data. All right, so it's gonna have a data chunk. And the trick here is, all right, int calorie count is what do we do at the end of each one? So we have to have a function here. We have to have an action. All right, so we're gonna say action, and this thing is gonna take in an int, add or on, I'm gonna call it on elf count. So this is sort of the function. This is the action we're gonna take at the end of each elf's calorie count. All right, so in this case, it's gonna, so instead of calling this here, all calories that add, we're gonna do on elf count dot invoke calorie count. Okay, so the idea is that was the only thing that's different between these two. This one, we have this if that sets up our max calories, and this one has this chunk here. Okay, so now the idea is I should call process data. It's gonna take in my data, but now it's gonna take in the function, and the function that I'm doing is gonna be all calories dot add. This is gonna be calorie count. I'm gonna add that calorie count here. And I don't need the variable calorie count. So now I have this function process data, which lets me eliminate, oh, I don't need it. I already took it out. I'm gonna be able to get rid of this chunk here. Get rid of calorie count. Now I have process data, my data, and then the action I want to take is going to be to take the maximum of either max calorie or calorie count. So max calories is going to be equal to math.max max calories calorie count. All right. Check that out. Let's test it. If I call part 2, I still get that. Let's call part 1. I still get that. So I recognize that I was copying this code here was essentially identical between my two functions. And I decided to go ahead and take care of that. All right, so now in the one, the loop is the same, but the way I combine that data, the way I aggregate that data is different. All right, now that I have all calories down here sorted, rather than doing just, let's see. Yeah, I have the last 3. Again, you'll notice this is an aggregate thing we're doing here. Let's see if I can actually use the built-in aggregate. Last element dot aggregate. In this case, the function said I just want to add them all together. So my aggregate function has to be A, B goes to A plus B. Okay, so this is gonna aggregate each element. It's gonna say for every pair of elements. So start on the first element, add it in there, sum them up, And so now we're gonna do int total equals aggregate like this. I can lose this chunk here, and I have my total. Let's do part 2. And there we have it. There we have it. The question I have is, can I do this nicely using LINQ? I don't think I can, because I sort of have to chunk out those things. ZC, welcome back. Welcome back. ZC is asking me, can you explain me a little about OOP, object-oriented programming? So, yeah, I can explain a little bit about object-oriented programming. This is an excellent question. The idea. So let me first ask. Do you know what a function is? Do you know what a function is? So we have, in programming, we have functions and we have data. Those are sort of like the two things, and really functions are basically data. Okay, so we know what a function is. So this is a function. The idea with object-oriented programming is to pair your functions and your data together. So if you have some data that is going to be using a function, so notice right here, my function, I say, well, this thing operates on a string array of data. Well, I have to explicitly pass in that string array of data. If I make this into an object, I can have a function. I might have this data might be associated with that process data. So let's rewrite this as an object-oriented style. Let's rewrite it in an object-oriented style just to give you an example. But the main idea is you pair functions and data together. So data that should operate on those functions get sort of combined together. And it sort of is this nice way to model the world. So let's talk about what this puzzle is. How long have you been here? Do you know what I'm doing with this puzzle? So in this puzzle, we're sort of calculating the calories an elf can consume. So we have this input file. Oh, this is the output file. We have this input file here. And every blank line represents a separation of a chunk of data. All right, so the idea is we have elves each carrying different amount of snacks, and this is the calories in each of those snacks. And so each line sort of separates the snacks that are being carried. And so if I wanted to represent this as an object, I'd say, okay, well, I'm going to create a new file here. I'm going to make an elf file. And I'm going to say public class elf. And a class stands for classification. Okay, the word class stands for classification. We're classifying a type of data which happens to be called elf. Okay, so in programming, your variables have data. Your variables represent some data in memory, and classes allow us to define sort of composition of data. So we're going to say an elf happens to have a list of snacks. All right. So in my elf here, I'm going to create a variable for this elf that's associated with this class. All right. So every elf is going to have this property. So the property is going to be that every elf happens to have a list of integers, and these are their calories. Okay. So every elf is going to have a list of integers. So this elf, the very first elf, is going to have a list with one thing in it. It's going to have this integer. The next elf is going to have this chunk of integers. The next elf is going to have this one. So every elf has their own list of integers. Okay. And so the way I'm going to do this is I'm going to create what's called a constructor. We have to know how to make this data. So public elf, and it's coming from a bunch of strings. So I'm going to do a string array data. So the elf is going to be passed in a string array of data to construct it. So this elf here would get these 4 strings as input into it. And then we have to sort of convert it into this calories thing. So we're going to start out by saying, okay, well, this dot calories. When we see the this keyword, it's saying the data that we're constructing, we want to refer to this variable, the variable associated. So this is just sort of a special keyword in C# and Python. It's called self. It has various names in different programming languages. And so now we're going to start out by saying, well, make a new list. So construct a list. This list is going to be empty by default. And now we're going to loop through this data and populate this list. All right, so for each string item in data. So we have this for each loop that says go through every element in data, and we're just going to convert it to an int and add it. And we're going to do this dot calories dot add int dot parse item. So this is how we int dot parse lets us convert a string into an int, and then we're going to add it to this elf's calories. Okay. So this would be how we can now create this object. Let's go back to my program. We're going to move all of this stuff to the bottom. We're going to ignore that for now. I have this code here. It's reading in my puzzle input. And I need to loop through. So I'm going to loop through. This is all of the inputs. And what I'm going to do is I need to loop through and build up the arrays that I'm going to pass into this thing here. Oops, I didn't mean to close my elf file there. So for each string line in data, so we're going to loop through it, and I want to build up. When I get to a blank line, I know I'm at a next elf. I'm at another elf. All right, so I have my statement here. Oh, I was sort of cleaning up by saying if string clean equals line.trim. This is just going to make it so that the string doesn't have any white space on either side. Or let me, before I even read this in, let's make an elf. So I can do elf elf 0 equals new elf. And because I've specified in my constructor that I need an array to make this elf, let's go ahead and make one. So this elf's gonna have a string array. I could do this 1,000, 2,000, 3,500. Does it let me do that? I think I have to say this is a new string array. Okay, so I can construct this elf, and it happens to have these values inside of it, so given some data. And now I can construct a second elf. Let's do another elf, elf1. It's new elf, new string array. And we're gonna say that this elf happens to have 5,333 and 27. So those are the two elements that'll be inside of this elf. Notice each one of these elves has their own variables associated with them. So I can do elf0.calories and elf1.calories. So I did elf0.calories at index 0. I'm gonna get two different values. So in memory, this variable is associated with that chunk of data. I know, it's because I made a mistake. I don't know if I made a mistake. Why are we taking in strings? It happens to be based on the puzzle. You're right. Let's change it. Let's make it taken an int array calories like this, and then we're gonna just loop through here. This is much better. Let's fix it. It was taken in a string just because my input was that way, but I'm doing an example here. All right, so I've changed it now. All right, I went back. My elf now takes in an array of calories, and it sort of adds those calories to a list. It's gonna break all of this stuff, so let me fix it really quick. Okay. Okay. I moved fast? That was a lot. That was a lot. ZC, are you following me? Are you following me? Did I do too much? So the main idea here is we have this elf class. I know I was fast. All right, so I'm gonna review. We have an elf class. All right, class stands for classification. It's saying there's a type of data that we're gonna call elf. We have said that an elf has a list of calories. All right, so elf has a list of calories, and to create an elf, this is called construct. To create an elf, you have to give us an initial list of calories. All right, so you have to provide an array of calories. When we create the elf, we're going to initialize this list. That's what this new keyword does. It says create a new list. The list is going to be empty, and then we're going to loop through this array of integers that was passed in. We're going to add each one of those integers into this list. So we're sort of pulling them over into the list. All right, so every elf is going to have its own list of integers, which represent calories. Then in our program over here, we created two different elves. All right, so we have elf 0 and elf 1, each with their own list of calories. So these are what are called objects. The object follows the specification of the class. So the class is like a blueprint. We've said this is the contract. This is how elves work. And now we're saying, all right, now we have an actual instance of an elf. We're going to construct. So that's why it says new elf. It says make some data, run the code in the constructor, and initialize it. So now we have two objects that follow this classification, follow the class definition. All right, so we have elf 0 and elf 1, and each one has their own calories variable associated with it. All right, so for example, elf 0, calories at 0 is going to be this 1,000, and elf 1 calories at 0 is going to be this 5,333. So they have their own separate data. They are objects in memory that have their own independent data, but they share the same interface. You can refer to them the same way. We know how to interact with these because there's a classification for that object, for that data. How am I doing? How much is that making a little sense? Okay, so that's the first part. Objects allow us to create a specification. In other programming languages, it's called like a data structure. So far we've just created a data structure. Object-oriented programming, we also can have methods associated with our data. So they're called methods. You have functions associated with an instance of the data. These are called methods. All right, so let's add a method. Let's say that we want to have elf be able to get additional calories. We might write a method. I'm gonna make it public. Don't worry about the public part yet. That's just saying that we can access it in another file. Public add int calorie. Or I'm gonna call this snack. Okay. So I'm going to add a method called add. It's going to take in an int. And what this is going to do is going to take the calorie associated with a specific instance that happens to be this instance. And we're going to add that snack to the elves list. So that's the first one. We want to be able to give elves additional snacks. We want to also calculate the sum of total snacks, total calories. All right, so this one's called a mutator. It lets us modify the object. This one's called an accessor. It says tells us something about it. So in this case, total calories is going to be the sum of the calories in this list. So I'm going to do int total. So snack is an argument. So this is a parameter to the add method. The only member variable is calories. So the only data associated with an elf happens to be calories, but how we interact with that data happens to be the method. So this is the ways we interact with that. So down here with calories, I'm gonna say total equals 0. Then we're gonna loop through item in this dot calories. Total plus equals item. So we're gonna sum these up and then return the total. All right. So this method operates on an individual elf. And that's where this keyword this is coming from. Saying the calling object happens to be the this. So let's go back over to program real quick. So on elf 0, I can say give me the total calories. On elf 1, I can say total calories. And I can run this. And it's going to give me the sum of these values. Notice that elf 0 and elf 1 have their own method, right? Even though the method has the same name, it's part of the classification. The code that runs is slightly different. In fact, the variable that's running, the this keyword, is referring to elf 0 or elf 1, whichever one is the calling object. If we were using just functions to do this, we might do the following. All right, so if it was a pure function, how would we write this function without it being on an object? It would look like this. It'd just be int total calories. And we need to know what the this keyword is. All right, so we would, in this case, we'd say elf, and I'll just call it elf. And we substitute it in there. So methods, this is what's interesting about methods. The calling object is essentially a hidden argument in many object-oriented programming languages. And we use the this keyword to refer to the calling object. There are programming languages like Python where you explicitly have to pass it in as the first argument. How are we feeling? Did this, ZC, tell me, did this make any sense? Did we make any sense here? Okay. But that's the general idea. So object-oriented programming, it happens to be a way to, so as a programmer, your whole job essentially is to manage complexity. And using object-oriented programming is one way you can manage complexity. It says, how should I think about my data? How should I apply my data? Let's look at another example. Let me open up a program I wrote recently. What was it? Let's see here. I recently refactored a C# program. Someone had written a C# program. Let's see, do I have it here? CD J Collard, CD chess. There it is, chess app. Let's see if we can look at it a little bit more this way. All right. So here I have a chess game. Here I have a chess game that I've refactored, and I've decided that these are the different things. These are the different things that I need for a chess game. So I have this idea of a king piece. Okay. So a king piece is just like all other pieces, except it has this special rule for moving. So it allows me to say, okay, well, I have pieces. All right, so all pieces have some properties, but the king piece is an object that is just like other pieces. So this concept of a piece, but it has special logic. So each one of my pieces has sort of this sub logic associated with it. Rit, so nice to see you this morning, or for you this evening. 6:30 a.m. here for me. ZC was just asking if I could talk about object-oriented programming a little bit. Pawn piece has some relatively complex logic. You don't think of the pawn as being the most complicated piece in chess, but it absolutely is. All right, so the idea is you take your code. So the basic idea with object-oriented programming is you take your code and you chunk it out into different logical pieces. Different logical pieces where you have data associated with functions, and that's called an object. And then there's various different ways we go about it, so like we encapsulate data. So the abstract piece, of course, is essentially the most complex, but we have this interface here. So pieces have get moves, a thing called logic, what they look like. So we have defined what a piece object should look like. And then you go and you say, okay, well, now this piece happens to be this way. I'm going to send you a link real quick too, so you can look at it later. Oh, I actually have my blog working now. It doesn't work great on mobile yet, but this is an article. Great question, Rit. I love functional programming. But object-oriented programming is super important as well. I just posted a link there for this article I wrote. I took a program that had no object-oriented design, and I go through the whole process of how I refactored it to use an object-oriented design. So ZC, I highly recommend checking it out, reading through it. It's a bit long, I know, but hopefully it'll help you a little bit understand how I used object-oriented programming to manage the complexity of this application. Cool. And of course the source code's available. But yeah, OO, super important skill to have as a software engineer. It's the most, as far as I can tell, it's the most widely used form of programming paradigm is what it's called. It's the most used programming paradigm from what I've seen. A lot of people struggle with object-oriented programming, not object-oriented, with functional programming, but I love functional programming. All right, we got a little distracted here, but we got the advent of code. We got our solutions in for the advent of code. And so my next goal, let's see, I have about an hour here before I have to hop off and teach a class. But next term I'm teaching a class on Unity. So my goal was to see if I could do a little bit of sketching out of how I want to, like the type of application, the type of puzzles I want to do. So I'm gonna open up Unity here. I'm gonna create a new project. Let's get a GitHub repository going for it. I want to make a, well, there's a couple different assignments I might have for my students. So, the biggest benefit of doing purely functional programming is that you eliminate the most common types of bugs in code. So when you're doing functional programming, you don't have side effects. So what I tell my students when I teach the first thing I tell them when I teach a functional programming language is you're programming without variables, which is true, but it's a little bit misleading. Everything is a constant if you're doing purely functional programming. Everything is constant if you're doing purely functional programming. There are no side effects. That's the whole idea with functional programming. There's no side effects. You're essentially defining a solution to a problem when you do functional programming. So it requires a little bit, in my mind, from what I've seen my students, it requires you to think through the problem before you can actually start coding, because the problem definition has to just make sense for the code for you to even be able to write the code. So I think a lot of people struggle to plan ahead. I loved functional programming. Haskell for a long time, I'm going to say Haskell is my favorite programming language. It's not the language I'm the best in anymore. For a while there, I did all of my programming. I made myself say, I'm going to learn how to do Haskell. And I programmed exclusively whenever I could, not quite exclusively. If I was able to, I would program something in Haskell. All right, so we are going to do in Unity here. We're gonna do something. I'm teaching a Unity class next term. One of the things I think I want my students to do is to build an adventure game, just sort of like a point and click adventure game where you can move stuff around, not necessarily move stuff around, but you have like some data, some scenes, you click and you move around on the screen. So I wanted to toy around with how to do that. The other thing I might do, and I'm definitely gonna have them do this towards the end, is write a Tetris game in Unity. Ooh, ZC's asking about GitHub. Yeah, GitHub. Oh, that's right, I was making a repository. Let's get that back up here. And I should push my solution. So there's this little thing here. So GitHub there's this idea of something called subversion control. Have you ever? Oh, I'm in the wrong project here. Let's close this. Sorry. So GitHub. Well, let's talk about Git first. So there's this idea of a tool called subversion control. All right. So I'm sure almost everyone's done this thing where you're editing a file and you're going, well, I need to make changes, but I don't want to mess things up. So I'm going to make a copy. So you end up with like program. So I might have program here or elf, and then I'll copy and paste this and name it elf version 0 and copy and paste it. And as I work, I have all these different versions: elf version 0, elf version 1, elf version 2. So elf 0, elf 1, elf 2. You might go through and make multiple different versions like this. Okay, so this is just like a common thing that people do. And you call these versions. So you have different versions of this file, right? So you have different versions of it. The idea with a subversion control is that there's a tool, rather than having to name it version 0, version 1, version 2, you have a program that manages your versions for you. So you have subversions. That's the whole word, subversion. And people still use it today, but my first version, there's actually used to be a tool called SVN, which stands for subversion. It lets you subversion stuff. I think it's Linus Torvalds, created a new version called, ZC, that's exactly right. It's about organizing different versions of the same documents, not even code. It doesn't even have to be code. It could be text documents, it could be whatever. Usually it's text documents. Images and that sort of thing don't do too well, or harder to find the difference. So Git, not to be confused with GitHub, is a subversioning program. So it's a version control system. So Git allows us to create subversions. And so I'm going to show real quick here. I'm going to use the command line. If I do a git status, it says, hey, you're doing something here on a branch called main. So don't worry too much about branches, but it's saying, hey, you have untracked files, and in VS Code we get this nice thing. These U's here are telling us that we have untracked files. These things that are untracked are not being versioned. Okay, so I can do here, I'm gonna do a git add on these. Am I in my fat elves? Yeah. So git add. I want to create a version for my day 1 CS project. And now it's saying, okay, I added this to be version that's telling me if you actually commit. So there's two things. You stage files. So you say, I'm getting ready to make a version of it. So let's go ahead and add everything here. I don't want get reset output. I don't want my output, but my puzzle input's okay. So I'm sort of saying these are the things I want to do, and then I actually want to create what's called a snapshot. So the snapshot is an actual version. So I'm going to do a commit, and the commit is saying all of these things that I've just added, all of these changes I've made, go ahead and make a snapshot of that. And so I'm going to put in here, for me, my commit message is going to be feat, that stands for feature. And of course, I've actually kind of botched my code here a little bit, but this will be a great demonstration. Feature completed day 1 of advent of code. All right. So now this is saved in my local repository. So it's only on my computer, but I can actually go back to previous versions. All right. So I made this commit here. It comes with this hash code that says this is that version, but now I can go back to previous versions. So if I do git checkout on a previous version, I go back in time. Check it out. When I first created this project, there were no files in it. And so notice all those files in my VS Code are gone. They're gone. It's like, oh no, I killed them. But I can go back to that by doing a git checkout main, and it brings me back to the snapshot I just created. All right. So if I were to do a .NET run here, it doesn't actually give me the solution. It's not giving me the solution because I modified my program CS, so I can be like, oh shoot, I want this to actually be the solution to part 1. So part 1, like that. So I changed my code. Oh, it requires me to pass the data in. All right, so now I run it. Okay, here's my part 1. I can now make a commit. All right, so git status. The cool thing is it shows me, hey, when I do a git status, you have modified program.cs. It's different than the version that is most recently committed. So I'm on what's called the main branch. This happens to be the most recent commit on that branch. And we have our file here. Program has changed. I can see that. I say, okay, well, I've made changes. I like these changes. I'm going to add it. So I'm going to do a git add on my program.cs. I'm going to do a git commit. I'm going to put down chore update program.cs to output part 1 solution. All right, so now I have that version. That version is saved here. And if I do a git log, it shows me the snapshots on this branch. And I can actually say, okay, well, I'm gonna go back. What did I do here? Git checkout. Oh, I made some changes I didn't like. I can go back. Look, my code has a snapshot of that version. So that's the main thing with Git. Git is a tool for doing subversioning, creating different versions, but you don't have to rename your files, do anything crazy. It manages it for you, create snapshots. Okay. Let's check out main here. GitHub. Let's do a git push. GitHub is a platform that hosts remote Git repositories. All right, so it hosts remote repositories. So now that I did this push, I said git push, that what that does, it says take the changes I've made, take all of my snapshots and upload them to a remote location, to my remote, and that happened to be GitHub. So if I refresh this here, you'll see that 1 minute ago, I did a push to my day one Fat Elves folder. This directory got pushed up here. And look, I have 3 commits. I can say, hey, here are the 3 commits. That's the message I created. I'm the author. And I can go back. So this is just like a nice interface. GitHub happens to be just a really nice interface for browsing repositories. And go, oh, this is all the files that got added here. It shows me just the differences. If I click on this, you'll see the only difference was I deleted all of this and I added this here. So GitHub hosts Git repositories, and Git is the tool for interacting with Git repositories. Does that make sense? Making sense so far? So you might ask, why do I want a remote repository? Why do I want my stuff out there? Well, having it remote allows you to more easily collaborate with other people. Can you imagine back in the dark ages, pre-internet essentially, working on a code base with multiple people? That would have been crazy. You would have to like have disks and stuff and trying to be like, oh, here's the newest version. You come and you have to figure out how to merge code. Crazy. I can't imagine having to work on a team of programmers pre-internet, much less pre-version, version control. That would have been horrific. It would have been a nightmare. All right. So then in a nutshell, we'll say, yeah, without internet, I don't know, man. I don't want to go back to the dark ages, pre-internet. that would be horrible. We're living in the best time, I think, for nerds like me. All right, so Git also has some nice features about branches. All right, so like I said, we're on the main branch. So this is where all of our code sort of goes. Git provides tools for collaboration. So the Git program provides tools for collaboration. Like I said, you don't want to be working in the same code. You don't want to be modifying code at the same time as someone else. It's going to cause problems. So the main idea here is you have something called a branch. So I'm going to create a branch here. I'm going to create a new branch, and usually you do it for my company. The company that I typically do is I say branches, whoever owns that branch, whoever is the main coder on that branch should prefix it with their username. So I'm going to do jcollard because that's my username. And then you would say what you're working on that branch. So I might say jcollard day 2, or I guess this is day 1. So do jcollard day 1. So now I have a divergent set of commits. I have a divergent set of commits that allows me to work separately from someone else on a different branch. So if I were to make changes, so let's change this here to do part 2. All right. And I'm going to add in my program.cs and I'm going to commit it here. Chore update program.cs to output part 2 solution. And I'm going to push this up. So I have to say push-u. This branch right now is only on my local machine. The remote repository doesn't know about it. If I come back over here, it has no idea. It still thinks there's one branch. No commits have been made. This -u is saying push it up to the origin, which happens to be the GitHub repository. And I'm going to say push up my branch. All right, so I push my branch up. And if I refresh here, the main branch has not been modified, so I haven't made any changes to the main branch, but I can go over here and say, okay, well, jcollard happened to make a change on the day 1 branch. So there's a branch that has changes, and so if you had 50 developers, they could all be on their own branch working separately, and you wouldn't be worried about clobbering something someone else is working on. All right. So that's the main idea with branches, is it gives you a place to independently work on your progress. And then when you're ready, let's say you're okay, I finished a feature, I got something working nice on my branch. That's when you do a pull request. Pull request allows you to say, I would like to merge. I would like to merge my branch with another branch. Take some code that I've written and combine it with someone else. So you create a pull request. The pull request is pretty common in places, but pull request happens to be a GitHub feature. As far as I know, the Git tool command line doesn't have a pull request feature. All right. And so when you're doing pull request on GitHub, you can see really nice, say, okay, well, this is what's called a code review. You'd go and you'd say, well, I'm going to review the changes. I'm going to review your PR. And you can see, hey, look, here's the difference. You go, okay, we went from part 1 to part 2. I like this. You'd add in your review. You might be like, okay, oops, beautiful. I like the number 2 better. You'd approve it. Oh, I can't approve myself. You might request change. You might just post a comment. We'll submit the review. And then you would eventually come down here and merge it in, like so. And so now this is going to take all of the commits from the jcollard branch and add them to the main branch. There's a different ways to merge. You might do what's called a squash, where you say, well, I'm going to take all those commits, reduce them down to a single commit and add them. You might do a rebase, which does something similar. And then ideally, we're done with this branch, so we delete it. And now we're back to a single branch. And my main branch has all the commits on them now, got merged in. Okay, all right, I hope that was Git and GitHub in a nutshell. Git is a program for managing Git repositories. GitHub happens to be a place to host Git repositories, and remote repositories allow us to more easily collaborate with each other. That's Git in a nutshell. Beautiful. I'm glad to hear it. Okay, so as I was saying before, I am trying to develop some projects for next term. Next term, I am teaching a Unity class, so students have had at least one term of C#. So they have C# down. They know the basics. They know, some of them have multiple years of programming, not all of them, but all of them have had at least one term. So they know about methods, loops, variables. Some of them know the basics of object-oriented programming, but not in great. So we're doing it's an object-oriented class with Unity. Two of the project ideas I have, I definitely want to have them make a Tetris game at the end, but one of the ideas is to have them create sort of a point-and-click adventure game. And so I'm trying to decide whether I want to work on Tetris or point-and-click adventure game. I'm not sure what I want. I think Tetris would be more fun, but point-and-click adventure game, I'll have to explore that idea. I haven't quite done that myself in Unity. So I suppose that's probably what I should work on. But if anyone watching has a strong preference, let me know. Oh yeah, so that's why it's the whole reason I went over here. I was gonna make a repository for this project. So I'm gonna create a new repository. We're gonna make a repository called Unity Adventure Game Prototype. Okay, we'll go ahead and initialize a README, and we'll say that this is gonna be a Unity project, so add in some default stuff for us, create this repository. And we'll go ahead and clone this out. Get a terminal going here. Git clone Unity adventure game prototype. All right, and that's where we are going to put our project. So if we go back to Unity Hub here, 2D, we need this to go in Unity Venture Game Prototype, right here. Okay, it's gonna be a 2D. We're gonna call this Adventure Prototype. Create this project, and then this might take a minute or two. Well, it processes. There's Unity building the default project for us. So yeah, I want my students to learn the basics of Unity, how to set up scenes, how to add scripts. And so I'm thinking I'm gonna build a library for managing an adventure game and teach them about using APIs. So that's the main goal I'm gonna have here, is setting up locations, tools for connecting locations together, and displaying things on the screen is what's gonna be up to my students. My students have to learn how to use callbacks in Unity to interact with a code base. I guess I should have started this while I talked about GitHub, because this is gonna take hopefully not much longer. I didn't realize it was gonna take this long. It's a little bit slower than I had hoped. It's already been a minute. It's probably gonna jump up here. Progress bars. All right. Well, there it goes. I was about to move on to something else. It's gonna trap me every time. It's gonna trick me every time. Here we go. Do 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 do. And for anyone curious, which is probably no one, we are listening to Candy Shop Stream Beats by Harris Heller. Makes a bunch of royalty-free music, which is great for streaming, great for videos. Good stuff. While this is loading, another thing I like to use, opengameart.org, great place to find assets for game jams, for building stuff. I always recommend this to my students when they're looking for something. For the most part, these things are completely open source. All right, Unity. We're gonna skip the version update. It's saying there's a minor version update. All right, here's my Unity window. My other monitor is a little bit bigger, but let's shrink this down so we can have Unity open here. Boom, boom. Okay. So I want to create sort of an adventure game. And the idea is that you can have sort of scenes on the screen and then clickable things. So this activity is going to teach students about creating UI, user interfaces. And so the first thing we're going to have to do is add in a canvas. Where is create UI canvas? Okay. And I have to relearn some of this stuff too, because we're in Unity 20. Oh, we're in 2021. I should probably be using Unity 2020. I probably should have done that. What's their longs? Let's see which. Oh, now I'm gonna have to recreate Unity LTS version Which versions are LTS? I think it's 2022. Oh no, 2021. Okay, maybe we'll use 2021. Doesn't matter that much, it's mostly the same. The one thing that I know is different is that the text has changed, hasn't it? Oh no, it hasn't. It hasn't. So it is this new text thing that I'm not sure how to use. Okay, so we have this canvas, and I'm learning things. So bear with me. I don't know exactly what to do, but the canvas here, we have to say how we want it to be rendered. It's gonna render over the whole screen, but I also want it to scale with the size of the screen. Okay, so the idea is it will resize with the screen. Let's add some text on there. UI, text Mesh Pro. I'm so used, so I'm gonna have to figure this out. I'm so used to using this legacy text, these legacy buttons, that I might just go ahead and do it, rather than trying to learn these new inputs. But I'm experimenting, so let's see if we can learn some new inputs. Some little window popped up for me over here about importing essentials. This appears to be the first time you access TextMesh Pro. As such, we need to add resources to your projects. Oh, I don't like that. Let's do it. Gonna add text. The examples and extract contains additional resources and I'll make discovering and learning. All right, we're learning, so we're gonna import that as well. Maybe we'll see how that goes. Okay, so we have those imported. Where is it on my canvas? There we go. New text. My game preview. All right, so the idea here is that no matter what my resolution is, this should scale up. I think if I didn't make my canvas do that, constant pixel size. Yeah, I want it to take up, this type of game is gonna, the UI is gonna take up the whole screen. Let's define a screen resolution, 1280 by 720. I'm cool with that. And so in our scene, I want to make it so that we always sort of have the title of the area we're in. So this idea that you're in a location, and the location is going to have a background and different things that change based on it. Let's go find some images to use here. Maybe a nice font too. But the layout sort of gonna be, what's interesting about this is a little tricky. This thing, I always want it to be from the top, depending on the size. We don't want it to overflow. We always want it to be centered, so the width of this thing should also be the entire size. Is that right? That didn't do what I wanted. I thought stretch left 0, right 0. Wanted to take up the whole thing, and then I'm going to actually have the text be centered. Oh, that's kind of cool. They have different text styles. That's new. I hadn't seen that before. Is there a center option on text? What is that? Ooh, fancy. We got some fancy materials there now. There we go. Just had to scroll down, alignment, put that in the center. This is gonna be room or location name, like so. We'll have a little text box at the bottom as well. So location name will be at the top. You'll have sort of, the idea is you have like a little bit of a viewport and then a text description down at the bottom. So it's sort of a fancy text adventure. All right, so we're gonna rename this to be our title or location name. All right. And it shouldn't matter what size you're gonna have, it'll always be centered like that. Okay. Let's add a I want like a dialogue box component. So I'm gonna go over to my open game art and see if I can find one. Here we are. Let's search for, well, we're gonna browse 2D art. Search for dialogue. I am not the submitter. I don't know why it does that. Let's search. Dialogue box. What do we think of this? Oh, that seems okay-ish. PSD. Let's download it, see if we like it. Go into our Unity. Oops, wrong spot. Jake Hollard. Unity adventure game prototype. Create new folder. Possible assets. Dialog box. And just in case I use this, let me log in so I can add this to a collection. Add to collection. Oh, wrong collection. Do I have to make a new collection ahead of time? All right, let us go here. Collections. Create a new art collection. This collection will be adventure, Unity, adventure, prototype, art. I am considering for the adventure project prototype. So I want to keep track of where all these things came from, so that way I can credit them later if I decide to use it. So now let's refresh here. I'll add that to the collection so that I have it for later. All right, let's actually look at what this looks like. And basically take it. Cool thing is, this is public domain. Technically, I don't have to credit it, but I love to. Let's have a dialogue over here. We're gonna keep the palette. We're gonna close this. So I only want the actual box there. So I'm gonna see if I can get rid of everything else. This little thing here, I don't think it's gonna work without modification. Without modification, that will not work. Let me see if I can easily. I'm no graphics designer, so I'm never the best at this stuff. Never the best at this stuff. But can I sort of make this take up more? So my idea here is I'm going to see if I can make this cover up that little space there. And then we'll draw in. All right, so that is going to work for that. And then I got to get this sort of here. This is going to look awkward, I think. All right, let us do some pixel editing. Where is the drawing tool? I'm sure there's a drawing tool. Paintbrush pencil. I need it to be 1 pixel. All right, bear with me here while I do some minor editing. I want to use this color. We need to make that diagonal perfect. Oh, can I not? Oh, I need to have this merged down. All right, so how do I get that? I can never quite remember. So press enter. I want this to actually be there. Paste another one. What am I doing wrong here? There we go. There we go. I don't know what I did. I just clicked and it worked that time. There we go. Fill in the blank spaces here. Let us... Where's my eyedropper? Got it already. That's interesting that the colors are a little bit different there. I think it's just because... Alright, we're gonna keep going here. And then we can fill in this last color. Like that. How do we do? That looks okay. Okay, let's see if I can get this dialog box in here. Possible assets, dialog box. And let's export as a PNG. Export. Let's add that into our assets here. So we'll create a new folder. I'm not sure what to call this folder. We'll add it here. We'll figure out what it's going to be in a second. It should probably be like images or some folder. UI. All right, we'll do it. UI. Bad naming is hard. Naming is hard. Unity Coder, thank you for the follow. I appreciate it. Bring this dialog box in. I want to make this an image here. So we're gonna add into our UI, we're gonna add in an image. And we're gonna say that this is our source image here. And then ideally we can make it sort of take up this bottom area. It won't look too bad. Yeah, look at that. Look at that. Not too bad now, is it? All right, and we're gonna make this thing be centered and near the bottom. And yeah, centered near the bottom. Position X will be centered. Position Y. The anchor point I want to actually be the bottom of this thing. So I should say that the anchors, what would that be? 1? Eee, not what I wanted. Interesting. Oh, this is anchor. Change the pivot. The pivot should be on 1. It's either 1 or -1. -1 to be the bottom. And so it's gonna always be towards the bottom. 0? Oh, I guess it's supposed to be 0. All right, see, this is why I play with it. And then let's have it always be 10 pixels away from the bottom. And I do like it to be sort of stretched. We're gonna set it 10 pixels from the left, 10 pixels from the right. And let's make it 100, 150, 120. All right, so no matter what our aspect is, it should always sort of take up that kind of space. Beautiful. Looking all right. Okay, next I want to add in some text here, right? Some text here. Set another, so I'm gonna rename this as dialogue background. I'm gonna add in a new component, text. And let's get some lorem ipsum, because I'm bad at not having lorem ipsum. I'm bad at generating content. Lorem ipsum, generate a little bit of that. We'll still that. And we'll dump it in there. And the idea here, dialogue text. The idea here is to make this fit nicely in that area down here. All right, so we'll stretch it out like so. And the size, the font size seems way too big. Font size 36, let's try 12. Ooh, too small, 16. 20, there we go. That looks reasonable. All right, so dialogue will come in there. You'll be able to press a button, have it have something happen, and then there's sort of like a viewport where you can click on stuff over here. There might, so what I should probably do is make so you have like an inventory here. Maybe the location name sort of shows up over on the left, and then you have sort of a viewport, you know, Shadowgate style. So there's this game Shadowgate. Yeah, that's what we want. Shadowgate style, Shadowgate. Oh, there's a remake of Shadowgate. This is what I'm thinking of. Shadowgate. So you sort of have like your inventory, you have some dialogue over here, and then you can sort of click on things in the scene to make things happen. Yeah. Okay, so this is what we got so far. Where are we at here? I have 15 minutes left before I have to hop off. I want to, what do I want to do here? I want to make it so that I have an object that's sort of like location, and when the location changes, the name of these things change, and then have buttons that can show up on the screen that the user can click on to change, like have interact with a location. Yeah, that's sort of what I want. So programmatically, you design your game as like these location objects. So let's create a folder, and this is gonna be, what am I looking for? Adventure Quest. I like to call, I always end up calling things Adventure Quest. Adventure System. I don't know. I'm gonna go with Adventure. We'll rename that soon, but I'm gonna put some scripts in here. C# script, and it's not actually gonna be a Unity script. It's just gonna be a C# file we can use. So this is gonna be, and I'm just doing this as to get this in here. So we're gonna have this concept of a location. All right. I should probably call this iLocation, because it's sort of the interface is defining what a location looks like. Okay, we'll open that up here. So an iLocation, it's not going to be a mono behavior. iLocation, too many active changes. That's fine. We'll ignore that for now. Get's just struggling. I'm missing my get ignore file. Let's move that real quick. Copy, get ignore here. And then let's reload this window. All right. So my iLocation is not, the idea here is to define what a location must have. So an iLocation must have a name. All right, so a location has to have a name, and then also is going to have a description. So those are the two things an iLocation must have to begin with. And what I'm going for is that there's going to be some like game thing that says what location it is, and when that location changes, update this information. All right, so I'm going to create an object over here, and this is going to be our game controller. All right, so this is the thing that's sort of, maybe call it adventure controller. Adventure controller. This is the thing that sort of is managing the game state, the state of our game. Okay, and let's create a script to add to that. I'm gonna call this adventure controller. So this one is a mono behavior because I need to attach it to this object, but it's going to have an iLocation. Okay, so we're gonna make this public iLocation. I think I might not be able to make it using the interface. I might have to make like a Unity version of it. I can never quite remember this when I'm doing it. iLocation, this is gonna be our current location. All right, and I don't think this shows up. I should put this in a namespace here actually. We'll deal with that later. Let's attach our adventure controller here. All right, and it needs a reference sort of to the UI. And so I'm actually gonna create a parent object here. This is gonna be location info. And I'm gonna nest these inside of here. All right, so the idea is this location info is gonna have a component on top of it that's sort of like the controller for how this information gets displayed. So let's create another component here, another script. This one is going to be our location UI controller. Did I name that properly? I think I have this extra weird S in there. Oh, it's going to yell at me that I changed the file outside. Clear these. Expected. Oh. Auto generation. There we go. Let it recompile here. All right, it's happy. So the idea is I need references to my location name and my dialog text, so when something changes, it knows to modify those things. Okay. So let us. I don't need anything at start. We need to add in some fields here. So publics. Is it a text mesh? Location name and a public text mesh location, and I could probably just call this description and name. Okay, so by making these public, they should be accessible in the editor, so I can sort of associate those things together. So I'm going to say for this location info, I'm going to add this script here, and I'm going to say, okay. The location name happens to be this text mesh. Yeah, it happens. So it's this thing here. So I need to get a reference to that. So this text mesh, I do that. All right, in my scene, copy component, can I paste reference? Hang on. How do I get that over there? Want this, or maybe text message isn't the right thing. It's the text mesh pro. Hang on, the text mesh pro. All right, so I think I just have this wrong. It's the first time I'm using the text mesh. Text mesh. Is it Unity? Hang on. .ui Unity engine.ui.text. I might have to look this up. Let's go to Google real quick. 5 minutes. I gotta go in 5 minutes. Text mesh pro type text type. Let's look here. Game object, get component, text mesh. Change the text mesh pro text via. The reason you're getting the errors because you added text mesh pro. The game object, you were trying to get a reference to text mesh pro component. Text mesh. What does my import look like? Let's see. Text mesh pro unity. It's TMP namespace. Thank you. Thank you. Yeah, I'm just trying to figure out how to access it. Using, let's see. Using Unity engine .tmui.tmp. Hang on. Let's find it here. Text mesh pro. What's your namespace? Oh, there's my warning alarm. Let's do a quick start. Unity's documentation sometimes is quite disappointing. Let's see here. Text Mesh Pro Text UI. There an edit script? Ah, thank you. That's what I needed. That's what I need. Namespace TM Pro. TM Pro. Okay. So over here in my, I appreciate that so much, Unity Coder. Location UI, TM Pro dot text mesh pro. Let's try that. Public name. Let's see if that is the right use case. Thank you so much for that. I appreciate it. So my location name, one way to get it is to, no, it's not. Dot. What is the type of this? Text. You GUI? Is that what it is? Oh, I'm dumb. I can just look here. Yeah, it's Text Mesh Pro U GUI. Wow, that's a mouthful there. All right, so that allows me to add it in there like that. And then we can also, let's get, we got our name in there. We're also gonna have our description. All right, we're learning the new interface. I've used the legacy text in the past, but supposedly this is much better. So our location info, we're gonna get our dialogue text there. And unfortunately, I am out of time this morning. I gotta go prep for my class, my C# class. Gotta get a little prep for that, which I'm teaching in an hour. So we made some progress. Let's commit what we have here. I'm gonna add VS Code to my git ignore. Code.vs code, it's not code.git ignore. We want to add in our .vs code folders. Unity Coder, my current schedule is Monday, Wednesday. It's on my stream channel. Monday, Wednesday, 6 a.m. to 8 a.m. Mountain Time. So Arizona time, really. And that's the schedule I'm trying to stick to. Though I have been streaming daily. I have been streaming daily when I get up in the morning. I'm just trying not to have myself committed to it. But I will likely be here most mornings, 6 a.m. to 8 a.m. Pacific, Mountain Time, Arizona time, which happens to be Mountain Time right now. We don't observe daylight's time. Yeah, so if you look at my schedule, Monday, Wednesday is my typical. I'll be streaming Monday, Wednesdays. But because of the advent of code, I'm probably going to be streaming daily through most of December. All right, thank you for asking. Yeah, so if you want to know when I'm going to be streaming, check out that schedule. But thank you so much for hanging out. Thank you for your help, and have a beautiful day. Gotcha. I appreciate you coming and checking it out. I'll see you next time. Bye-bye.